Natural selection drives evolution, and it's been at work in this planet since life first took root. It makes for characteristics or adaptations that make survival of an animal possible and provide an advantage, such as the speed of a cheetah, shape of a beak, or the neck of a giraffe. Natural selection aids in the competition for survival, yet many animals pose characteristics that do not aid in this task. How does the extravagant tail of a peacock aid in its survival? Wouldn't it impose a threat and make it an easy target for predators? Why would nature allow for such oddities that seem to hold no survival benefits? To explain these odd characteristics, Darwin came up with a theory of sexual selection. There are obvious differences in certain species of animals between males and females, such as the mane of a lion, known as sexual dimorphism. If all animals follow natural selection, however, there shouldn't be any. Natural selection should affect both females and males the same, and yet there are vast differences in some species between the sexes that natural selection does not account for. Darwin said these differences were to advertise their health, stamina, and overall compatibility as a mate to the opposite sex. Since the female invests more in her offspring, she will be picky about her mate. She wants to hold out for the best genes, especially since their offspring have to survive long enough to have offspring of their own. Because females get to choose their mates, this allows for non-random mating. What kind of advantages does sexual selection offer a species? Diversity is a key concept to survival since our environment is constantly changing. Genetic variation offers a challenge to viruses, competitors, predators, to bacteria, or anything that might impose a threat to a species' survival. Each individual has a unique set of genes and DNA, which may provide a challenge to viruses or any other threat. Sexual selection also allows for the best genes to be passed down to offspring, such as a female gorilla choosing the strongest male gorilla to have offspring with. This allows for an advantage in the offspring. As environments change, so much selection. If there was no selection, then a species would hold no genetic variation and offer little advantages to changing climates, conditions, or predators.
The sexual process, which appears to be normal, predominant in most things, I study the diseases of sex, the pathologies of it. Little fish, in this case, that live in the Mexican deserts that have abandoned the sexual process. And the beauty of this is it's a natural experiment because side by side in these same little puddles, we'll have sexual reproducers, we'll have asexual reproducers, all competing in these tiny little simple environments. I could try to study this in a massive environment like an African savanna, but I can't manage an African savanna. With my capabilities, I can manage a few small pools like this, and for 30 years I've been coming back to this part of Mexico to study what goes on in these pools. We got some. We did good. This is a good sample here. Look at how black these fish are. Wow. Look at the pigment on them.
Early on, Weinhoek discovered that 40% of the minnows in these pools were heavily infected with a parasite that causes black spot disease. The rest seemed relatively unaffected.
When we brought them back to the laboratory and started counting the spots, we noticed, well, my goodness, this is really neat. The asexual reproducers were taking much higher loads of parasites than the sexual reproducers on average. Why should they be more parasitized than the sexual reproducers? They were living right beside because they're all being exposed to the same parasites in the water. There should be no fundamental reason for different parasite loads on these different kinds of animals, unless it had something fundamentally to do with being asexual as versus being sexual.
But what? The only thing to do was to keep walking and sampling and thinking.
Oh, look at this.
Finally, it hit him. He was looking at a real-world demonstration of the value of males, one suggested by an evolutionary theory called the Red Queen.
The Red Queen is an elegant idea. I think it's one of the great ideas since Darwin. And it goes back to a wonderful scientist, Lee Van Valen, who basically asked about, does evolution stop when things get perfectly well adapted to their environment? He said, of course not. Evolution is a race, and it's much like the race we saw in Alice and the Red Queen in Alice in Wonderland, where they were running just as fast as they can, and Alice says, isn't this curious? As fast as we run, nothing seems to change. We're staying in the same place. And the Red Queen says, yes, you have to run just as fast as you can to stay in the same place. You're living in a complex world, a world full of parasites, a world full of viruses and bacteria, predators, competitive species, all basically evolving too. And the moment any species stops evolving in response to these challenges and threats, it's doomed.
The cloned fish have stopped evolving. They're an easy target, especially for a short-lived, fast-evolving parasite. But the sexual fish are a moving target. Each is a new combination fashioned from its parent's genes.
So as far as the parasite is concerned, every individual in that sexual population is a unique and individual challenge, and that slows down the transmission of the parasite through the sexual part of the population.
Here was a solution to the mystery of
Sexual selection is divided into two different types. First law of battle, intersexual selection, competition among males for access to females, such as fighting and protecting territory. This type of sexual selection can be witnessed through physical characteristics, such as antlers or sharp teeth and claws or aggression. The second was generating characteristics that attract the opposite sex, even if they impose a threat to their survival. This makes it possible for sexual selection to be female-driven, giving the females of the species the power to choose the best candidate for reproduction. Animals such as the birds of paradise, which show great diversity in color, size, song, and attributes that some would say make them easy targets for predators, are excellent examples of these adornments and physically attractive characteristics designated for attracting females. But for sexual selection, avoidance of predators is not a top priority. The goal is for the animal to reach sexual maturity so that its genes may be passed down. Sexual selection has opted for these particular adaptations, such as extravagant wings and bizarre mating rituals, not because the animal reaches a ripe old age with them, but because it has allowed for the best fitness and females have selected for them. Females do not compete in the same way that males do. They do not need to compete for the best quality male, since males can mate with more than one female. Some female species might be competing for something other than sperm. Perhaps to have a wider variety of males to choose from. More males being interested in a female gives the female the advantage of choosing from a wider variety of genes. Or if males bring gifts such as food or territory, they might want to flaunt their fertility and readiness to mate in order to reap the benefits of a particular mate. In a way, you could say beauty plays a key part in sexual selection. Mammals give off different signs compared to birds. Mammals may exhibit some adornment, such as the mane of a lion, but more than likely, sexual selection is exhibited through signals or smells, things that are not as obvious to be picked up on by mere observation of physical characteristics. Many primates and mammals in general exhibit the law of battle, competing for territory, access to females, and resources. Sexual selection served to explain the many questions of evolution that natural selection failed to answer. Sexual selection, much like natural selection, is a necessary tool of survival and offspring survival for many species. It makes for odd physical and psychological characteristics in both male and female species.